live and interactive. It's such a pleasure to be here. It really is. A little bit of my our learning journey over the next 40 minutes or so. I'll tell you a bit more about my particular story of how I come to be doing this lovely job at Roehampton University these days. I want to look at the P word briefly and talk about pedagogies. I then have a section on pedagogies of ICT, pedagogies of computing. It would be helpful to know how many of you in the room teach ICT or teach computer science or something like that. Oh, that's probably about half, sort of trying to do the estimate from that particular collection of big data there, and then broaden that out to deal with more general issues of curriculum design, more general issues of different approaches, or different pedagogic approaches to teaching in general, drawing on the experience of an entirely different industry. So I want to have a look at what we as teachers, we involved in education, can learn from the industry of software development, particularly some of the sort of cutting-edge practices around this agile development, around this software craftsmanship movement. And I think there are interesting parallels there. I'll end up, if we have time, dealing with the particular elephant in the room, and that's pretty much where we're going over the next 40 minutes or so. So how did I get here? 18 years across 4 different schools, left as an exercise for those of you with a background in geography to work out which is which. So I did a couple of years at King's School Gloucester as a maths teacher there, doing a little bit of programming in the maths education stuff, then moved to Christchurch Cathedral School, boys prep school 3 to 13, and there as head of IT, head of maths, and then moved to St Ives School in Hazelmere as deputy head, but still got to do lots and lots of geeky things on the maths and IT side of things, so we pioneered the introduction of virtual learning environments in primary education there. Then moved to Alton Convent Prep as head, 3 years as a head teacher at Alton Convent Prep, hence prematurely grey hair, folks. I'm not nearly as old as I look, he assures you. And then moved on from that to the current job at Roehampton University, where I'm subject leader for ICT education and get to do other fun things too, which Ian's talked to you about. So this is where I work. Well, actually, that's where our Vice-Chancellor works. My office is made out of breeze blocks and some distance away from that particular bit of the campus. But like a couple of ancient institutions, Roehampton is a collegiate university, and I'm based in Froebel College, which has a long, distinguished history of teacher education. Any Roehampton graduates in the room? Oh, splendid. Happy memories? It's good to hear. Right. So Froebel was the founder of the kindergarten movement. And here's a 19th century German painting of a 19th century German kindergarten. I wonder, folks, do you think it would pass its early years inspection if they were to come to visit? Well, we have purposeful activity there. We certainly have learning taking place. I'm not entirely convinced that the adults present are necessarily directing the play there, but we've got a rich learning environment. And that, in part, is a big part of Froebel's philosophy of education, of providing the environment in which learning can take place. The other thing Froebel's known for is this notion of the Froebel gifts, which are a highly structured collection of presents or gifts that you give to a child during the first sort of 4 or 5 years of their development. And some of those look very much like building blocks. Why do we give building blocks like this to children? Why, when you go down into your pre-prep, do you have children playing with blocks that still, I hope, look a little bit like this? Is it because we want them to be construction engineers and architects and building workers later in life? Perhaps, but more likely, perhaps not. Isn't it through playing with these things that a child comes to understand a little bit more about how the world works? And through play, through experiment, through using toys like that, they come to get that understanding of reality and how much of that can be made true for ICT education too. Of course, people do take those early experiences and make jobs out of them. So Frank Lloyd Wright, great American architect, started his education in a Froebel kindergarten, and one wonders about the extent to which those early influences characterize some of his later work. So, those of you who are using Scratch with children down in primary school, in the primary phase in your prep schools, perhaps some of those children are going to become software developers and computer scientists, but that's not the reason why we use tools like that, I would suggest. Let's just deal with the P word here. On the way back last night, Ian Yorston and I talking about, the etymology of words, where words come from. And pedagogy is a really interesting one, because it doesn't mean what we think it means, or it didn't mean what we think it means. Look there, oops. Oh, okay. And on the big screen, that's a relief. Sorry, technology, you know what it's like. So what we have there is the pedagogue is the slave who took the children to and from school. Now, many of us, perhaps as pedagogues, feel like slaves from time to time. Don't put your hand up if your head teacher has accompanied you to the event today. But it isn't, the word there has this meaning of the person who takes the child to the place where learning happens. And I think it's worth keeping that in the back of our minds through some of the conversation that follows. So this is a slide which I show to a lot of our first years and our new postgraduates. And, this is learning styles. And I don't mean that whole vacuous VAK thing, which largely discredited now. I think when it comes to learning stuff with technology, we have perhaps these three different learning styles. We have folk who do like to play, to explore, to experiment, to discover things for themselves. We have folk who like to read the manual, who like to watch the YouTube walkthroughs, and we have folk who do very much like to have somebody to talk to about this. And I'd quite like a show of hands for this. And of course the answer is, Miles, it depends. But if you had to pick one of the three, could you put your hand up, please, if you like the toys, if you like to just play with stuff? Thank you very much. If you'd like to have the book to read, the manual, I'm old enough to remember when computers came with manuals. Okay, if you'd like to have somebody there to help you, somebody to walk you through. Okay, I suspect if you ask the children in your classes the same question, you're going to get at least that proportion in the first category, which looked about 2/3 of the room to me from here, of let me just explore, let me experiment. Is that not how so many of our young people learn to use the technology away from the classroom? And yet when we bring them into an ICT lesson, how many of us, self-included, will stand at the board with a computer and show them how to do things and say, okay, go on and practice that yourself there. And that's not how they would choose, or how we would choose to learn these things. So I wonder why we do it as much as we do. So I asked my students this question, which category do they come into? But I also asked them some other interesting questions, like, for instance, tell me the stories. Tell me an example of how you've learned something on a computer or learned to do something with a computer. And I just put a few of these quickly up on the screen there. Yeah? Common experience? I remember being taught that things I personally felt very comfortable with already, some cases, methods and programs that were obsolete. Sad, isn't it? Instruction manuals are for wimps. Still remember someone telling me that it was really, really hard to break a computer through incompetence. And that little mantra has stayed with me ever since. Isn't that a lovely thing? Isn't that the sort of message you would want your students going on from you with? So we do the statistical stuff as well. We ask them to grade themselves on a whole cluster of different IT skills, and then their knowledge, and then their understanding. And those things are quite different. And broadly speaking, folks, the students we get at Roehampton are pretty good on those skills measures. What's that? That's about 2/3 of them regarding themselves as competent or better. When it comes to their knowledge, that's somewhat less. When it comes to their understanding, that's a whole lot less. And okay, this is just Roehampton. This may be a self-selecting sample. But less than a quarter of them describing themselves as having a competent understanding of technology. Worries me. It suggests I've got my work cut out there. None of them describing themselves as expert when it comes to their understanding. So have we perhaps focused too much on providing them with skills that they can do things on a computer and not addressed enough that understanding of how the technology works? Isn't it time to start redressing that balance? Oh, when we cross-reference this with the learning styles, it's interesting that those who like to explore score higher than those who like to have the person to talk to there. Where's the interesting statistic? Look at the competent level again. That's like 1/3 of those who explore are competent or better, but only 15% of those who like to have the support describe themselves as competent or better. And I'm curious about the causality here. Is it that those who are willing to play develop that better understanding, or is it that those who understand it feel more confident playing? Which way round do you think it goes? Hands up, please, for confidence, or hands up, please, if you think that the exploration leads to more understanding. Thank you. Hands up for those who've got the understanding and more willing to play. That's really interesting. Okay, strong preference in favour of the former one. Okay, so who recognises the gentleman with the beard in the picture? Oh, come on, folks. Seymour Papert, who is the godfather, the pioneer for putting computers into schools. And, you know, like my Froebel blocks earlier, his vision wasn't so much about teaching children to program computers as an end in itself, but how much children can learn about learning, can think about thinking, can come to understand the world around them through direct experience of programming computers. So this is the sort of thing which he was writing back in 1980, 32 years ago, folks. You know, in many schools today, the phrase computer-aided instruction means making the computer teach the child. Any mathematics or education city users in the room? No, nobody admitting to it in public. Fine. One might say that the computer is being used to program the child. In my vision, the child programs the computer. Doing so both acquires a sense of mastery over a piece of the most modern, powerful technology and establishes an intimate contact with some of the deepest ideas of science, of mathematics, and the art of intellectual model building. Isn't that a noble thing? You know, this program will be programmed argument, Douglas Rushkoff's book, right there back 32 years ago, about taking charge of the machine and learning about learning through that experience. So yeah, putting children in charge of computers and having them make things for other people using the technology. And of course, back in those days, that meant writing programs. But these days, it's come to mean so much more about that and how much we learn through that experience of making things for other people to see. Both our students, how much they learn through that experience of making things for others. And of course, it's not just ICT or computer education. It's across the board where this notion of constructionism applies. But what about ourselves? Is that not our experience too? That when we make a lesson for our students, our understanding of that really does deepen. This is certainly what my students report back to me. Those of you who are in senior management roles, when you're putting together school policies or planning curricula for your school, isn't that how your understanding of the education process of what school is about really crystallizes, when you're making things there for other people to see? Okay, I want to talk a little more about curriculum, or just introduce a brief conversation about curriculum before we get back to pedagogy. Those of you who are teaching A-level ICT will be, I'm sure, familiar with the waterfall design methodology, where we start at the top there. We come up with a list of requirements of what the system has to do. We then design that. We put that into practice. We implement that as a bit of technology. We check it works. And then, okay, once in a while, we have to keep the thing ticking over and do the maintenance sort of thing. Everybody reasonably familiar with the ideas here, I hope. I'm getting one or two nods in the back of the room. Is this not also, though, how we've done an awful lot of curriculum design for quite a while now? We've started with, you know, the great and the good saying, children should be taught this, of coming up with a list of objectives of what a curriculum ought to contain, or a program of study ought to contain. And then, you know, groups of typically men in suits gather round in basement rooms and write that stuff. And then it's down to the rest of us to put that into practice, to implement that there in the classroom. Well, what about verification? Well, we do a certain amount of testing, or assessment, as I believe it's now called, don't we? I mean, actually, we do quite a lot of testing to see whether that's actually worked, particularly the implementation phase of that. And then once in a while we tweak things and we bring out ring binders and we introduce sort of schemes of work to deliver a curriculum a little better. This is fine. This works perfectly well for very large-scale IT projects like, I don't know, the NHS data. Okay, moving on. It's a fire and forget. Well, not quite forget, but does it actually work now? Does that really represent the best practice in software development, or I would argue, the best practice in curriculum design? Well, you know, we have national curriculum documents, we have GCSE specifications, and you have that delivered to you. Your job is just sort of implementing that in the ground. Here's Nick Gibb talking earlier in the year. There are big problems with this. He likes this idea. Look at the bottom paragraph. I will count it as a success when teachers are able actually to laminate their lesson plans and recycle them from September to September. Is that what you'd want? Isn't that really deprofessionalizing? Isn't that really not meeting the children, the students that you have there in front of you and thinking, look, it's just the same thing every year. I've got this perfect lesson plan. All I need to do is deliver this. It's a cathedral approach. And okay, I'm very privileged to have worked in a couple of cathedral schools in my teaching career. And cathedrals are lovely things. They really are. And somebody designs this great, magnificent edifice to the greater glory of God in this case, or to the greater glory of, I'm not quite sure what in the case of a national curriculum, but we have that, single, visionary construction there. And we come there and make the most of the place, the space that we have. There are, though, other approaches, and the cathedral approach to software development does have its fans and does have people who do really, really good work in there, but there are alternative approaches. And when one moves from a proprietary model of software to a more open source model, the metaphor of the bazaar, and I'm spelling that with an A, not an I towards the start of the word, is one which is quite appealing. It's not a single entity that has designed and built this. It's something which we each can contribute to, and we can each take something from, and we get to choose what we take away from a space like this, and we get to see all of the options that are there and find the things which are best suited to us and perhaps contribute something back in to the community, into the marketplace there. And I wonder perhaps if that's a slightly more helpful model for thinking about curriculum design, thinking about how we go about deciding what to teach. So moving from that waterfall model to a more iterative, cyclic model of curriculum design or lesson design. And yes, start with the requirements and analyze those, implement those, test those, evaluate those, but then keep going round the loop. And don't laminate your lesson plans, please. Put them on a word processor or Google Docs. Google Docs works very nicely for this sort of thing, and change them. The evaluation there ought to feed into the planning process. And you see this with something like Scratch. There's strong parallels there between the iterative cycle of software development and the sort of spiral that something like Scratch, which is from MIT's Lifelong Kindergarten group, there's a nice link back to Froebel for you there, has at its heart. If you start by imagining things and making things for other people to see and reflecting on that process and improving and improving and improving all of the time. And isn't that closer to what we ought to be doing in terms of our planning, in terms of our curriculum development? Is there anybody in the room who's not used Scratch or seen Scratch? Oh, you've missed such a treat, folks. Come and talk to me at lunchtime about Scratch. It is just such a nice way of children learning to program computers. So we make all of our students create games inside Scratch. This is something from our first years who've been coding up this little sort of drill and practice arithmetic test game. Not particularly sound pedagogy, I lack knowledge, but the act of making a computer program around that, such a wonderful experience, such a useful experience for them. And of course, Papert was way ahead of us, sees this as the proper use for drill and practice, not using one which somebody else has made, but getting children to make these things themselves. Because as they code up a game like this, they come to think about the process of learning and how we go about retaining things and making use of those and diagnosing the errors. And when did he write this? 1971. Have we really moved on that much further from that sort of understanding? Okay, so I've talked a little about iterative development. We talked about waterfall development. The title for the talk was meant to be about Agile Pedagogies, so let's look at that a little more here. So you have there, right at the cutting edge of software development, this notion of the agile methods, of methods which are not quite so constrained from the top or working through a lengthy cycle where you're much more responsive to change. And my argument here is that we as teachers can learn so much from the software developers. And I'm not thinking about this in terribly reductionist terms that software developers are programming computers to do things. We're essentially programming children to do things. It's not quite as simple as that. But I think there are strong parallels between the two. And surely, this is the Agile Software Manifesto. Most of us are actually concerned about the things which the Agile developers are concerned about looking at the individuals that you're teaching, that you're working with, and your interactions with them, rather than specifically the processes and the tools. Isn't that where our focus should lie? Aren't we concerned more about establishing working knowledge and producing comprehensive lesson plan documentation? Aren't we more interested in collaborating with, we might in this room talk about customers, but working with our students, working with our learners, rather than negotiating the details of learning compacts? Yes, about collaborating with them and acting as partners with them. And yeah, being responsive to the change, being responsive to what happens in the room. I'm sure you all have that experience of the best of your lessons are the ones where you didn't stick to the lesson plan, where the child asked the question in the room and that took you off at a tangent and you dealt with that because it came up. Isn't that the case? Yeah, that is a common experience, isn't it? Where, because of the things which they are interested in, we get to talk about those ideas and engage in that and not worry quite so much about the whole lesson plan curriculum delivery sort of thing, working with the people who are in front of us. So yeah, the things on the right are fine. They do matter. They are important. But let's move our focus into a more agile mindset and look at the things on the left-hand side of the screen there. So you then get into the detail of this, and these are the sorts of statements. This is the principles of agile development. I don't want to go through these bullet point at a time, but I'll give you a moment to read through those and possibly pause for questions. We're doing all right against the clock. Is there anything here which you want to pick up on or talk about now before I just go on and show you yet more slides?
Miles, can I just ask you to go back to the previous slide?
Yeah.
It seems to me that you've really captured the essence of the difference between the broad, enriching and collaborative education on the left, and that on the right is all of those will narrow down and thin down and winnow down into something that may indeed give the A star at the end very narrow.
It works.
It works, but sadly, it isn't going to give the broad, liberal 21st arts and sciences education that we're looking to provide.
Neither is it as much fun for us as teachers or for them as students, I would argue. But you put it beautifully yourself. Sorry, I interrupted you.
Well, really just to say that I think that's a critical slide, because on the right is everything that's narrowing the curriculum has been going on for so long. And every time, as we say, you go back to which bit is going to be laminated.
Yes.
So which one of those can you laminate? You can't laminate the stuff on the left.
No, because that changes. Yeah.
Where we as educators and certainly leaders in our schools need to be consistent reminding ourselves that stuff on the left is what gives us success in our schools. And
the software developers have figured this out for themselves. How long is it going to take before we as educators start to see this for ourselves? Okay, the people in the room perhaps already do, but surely, if the software industry has figured out waterfall development may not be the best way, that moving towards more agile methods gets things done much more effectively and is much more fun for everybody. Can't we sort of see that too as a community of professionals? Anybody else want to pick up on this or the next slide? I'll press on in that case. Okay, you then get sort of little approaches or movements developing within that whole territory of agile development. And one of the really interesting ones for me is this notion of pair programming. So my year one computing project, we make them work with a partner on that. And so we get much, much better games coded up than we ever did when we had students working individually on this sort of project. And isn't this also the case in our line of work, that when you have two teachers teaching two parallel forms, and where they actually do that sort of development work together, bouncing ideas off one another, sharing their insights, arguing about what should be on the curriculum. Doesn't that produce better curriculum, as in the case of better code, than it does when you have two people working entirely independently there? And, pair programming is a well-documented methodology. You have this notion of quite different roles. You have somebody who takes a driving seat position of doing the detailed work, and then somebody who takes the more sort of navigator-like role of seeing the big picture and seeing how one bit connects to another bit and looking at that sort of overall arch of the curriculum there rather than just necessarily the nitty-gritty detail. And I don't know, I suspect your schools are jolly well resourced and you don't have this business of two children working on one computer. But once in a while, it might well be worth doing that in IT lessons, of saying, okay, could you share a computer between you? And one of you use the keyboard, the other use the mouse. Or one of you be the driver, the other be the navigator, and try and produce something working together. Compare and contrast. Is that better than working individually? And then you have this notion of the development scrum. I think this is a lovely idea. So the notion is the Agile project team meet together every morning and they have this scrum meeting where somebody keeps them to really quite tight rules about this. And there are 3 questions that you have to answer in the scrum. What have you done since the last scrum? And what are you planning to do between this and the next scrum? And what are the problems you've encountered? And of course, you have a team that's working on this who can solve those problems, or they can, knowing what you're planning to do means that they know what they're going to plan to do. Is this not something which we could bring into our department meetings, into our staff meetings, into our staff briefing sessions? What have you done between yesterday and today? What are your plans for today? Is an interesting conversation to have. And what about in the classroom too? Why not do your plenaries as daily scrums? If they're working on project work, what have you done between the last time we met and today? What are your plans between now and the next time we meet? And what are the problems you've encountered? And I bet somebody in the room could solve the problems that they encountered. Team members should not digress beyond answering these 3 questions into issues, design, discussions of problems, or gossip. So there's something for staff meetings, don't you think? Right, okay. And then you have this sort of pragmatic programming thing, and I'm sorry that the formatting's not worked. Technology. That you have this, look, actually, let's focus on getting things done here and being pragmatic in our approach and focusing on, the things that matter. And I love some of the stuff on the right-hand side there. Do I have to do it this way? Is there a better way to code this in their case, or to teach this in our case? And look at that last one. Does it have to be done at all? Put the margin, put the learning objectives, put the date. All of this is about school. It's not actually about learning things, is it? Interesting stuff. Okay, who here has written software themselves? Who here can claim to be a software developer? Gosh, that's loads of you. That's so nice to see that. Do you think that, the argument around this computational thinking stuff is that those who write software, those who are doing the work of a computer programming, either as a hobby or for their job, start thinking of the world differently, and they solve problems a different way. They draw on a bigger toolkit of problem-solving techniques, like breaking problems down into smaller parts, like looking for the patterns there, like seeing what can be generalized, like not worrying about the detail because somebody else has solved that problem. Those of you who put your hand up as, yeah, I'm a software developer or I've written code, is that the case for you? You feel that you look at things differently? James not quite so sure about that? Well, the argument's there. Whether or not you buy into it, I'll leave to your decision. But head teachers in the room, directors of studies in the room, deputy heads in the room, people who think like this are a tremendously valuable resource for you to draw on, I would suggest. And if you're looking at implementing a new management information system or changing the way you do registration, then having a few people who can do the computational thinking stuff to talk to about that and see what are actually the smaller problems that we need to break this big problem down into. I think it would be useful for you to have somebody like that on those committees, somebody who can draw on this particular set of problem-solving techniques. And okay, maybe don't just make them the one person responsible for this, because there are other problem-solving techniques too. But being able to think like this is a tremendously useful resource. And why we're teaching, why we want to teach computer science in school is kind of because of the sort of skills which children would develop through that experience, or at least that's the argument. Okay, anybody familiar with the notion of a pattern language? All right. It started with this book, Christopher Alexander, talking about the problems of the common problems which architects and civil engineers and town planners face, that these are the sorts of things you have if you're building a house, or these are the sorts of problems you face if you're building a city. And there are good solutions to those common problems. So Alexander tried to codify that. If you encounter this sort of problem, this is a good way of solving that problem. So it's moving towards this notion of a design science, that with a particular set of problems, these are typical solutions to this. And this has been really taken up by at least some agile software developers. So you have this book by the Gang of Four about trying to find reusable chunks of code. So most programs are going to call on particular sets of ideas, particular algorithms, in order to solve the same sort of problem over and over again. So why bother reinventing the wheel? Why not just develop a language to talk about that and see, okay, we've got this sort of problem, this sort of solution typically works there. It's not necessarily the same as a library as code which you can automatically just plug in, but somebody solved the difficult issue of how do we do that, solve that sort of problem, and they put that into a book and call this a pattern language. That if the problem falls into this particular pattern, then the solution will fall into that particular pattern. And there are folk now who are starting to apply that to our job too. So Hoover and Osh and I, talking about this business of becoming a software developer, have this codified in terms of apprenticeship patterns. And for my line of work, this is really interesting. The process that one goes through to become a software developer, or their recommended process to become a software developer, is that really that different to what a teacher or a trainee teacher goes through in the process of becoming a teacher? Where are the parallels there? And, confronting ignorance, unleashing enthusiasm. Is that not something you'd want the NQTs or the student teachers attached to your school to be quite willing to do? That if that works for software development, then also for education. And then there's this group on the interweb, pedagogicalpatterns.org, who've tried to do this for a number of teaching situations. So if this is what you want to achieve, then here's a pattern language, here are a set of solutions which appear to work in that sort of context. I think it's really very creative work of looking at the way we plan a lesson and saying, okay, these are the sorts of things I want to happen. This is the sort of pattern I would adopt to do that. Diana Lorillard, talking about teaching as a design science, doing some really interesting work on that now and looking at that notion of applying this pattern language idea into education. She talks about teaching as a craft, and that's what I want to focus on briefly now. So, we think of the art of teaching, but we should perhaps, Lorillard argues, think more of teaching as a craft skill, because it's not actually about doing something for its own sake. Teaching as a craft because what we're aiming for is for the pupils to learn something. The imperative for teaching is that learners develop their personal knowledge and capabilities. It's closer to the kind of science like engineering, computer science, or architecture. Its imperative is to make the world a better place, a design science.
Teachers increasingly out of college and into the classroom.
Sorry, shock for us all.
Teaching is a craft, and it is best learned as an apprentice, observing a master craftsman or woman. Watching others and being rigorously observed yourself as you develop is the best route to acquiring mastery in the classroom.
Now, my colleagues in higher education have some issues around that. But if we take him at his word there and perhaps nowhere else, this notion of teaching as a craft, of an apprenticeship model, is in some ways an appealing one. And okay, that does kind of demand that the apprentice has the master craftsman to watch and to be attached to and to be apprenticed to. I'm not sure how many teachers that students get attached to are, in fact, those master craftsmen. But if one could do it that way, there's much that's appealing there. And Richard Stallman, again, talking of programming, not as an art. Donald Knuth writes about the art of computer programming. Stallman and plenty of others see software development much more as a craft, because you're making things that have to be useful. Yes, it's nice if it's beautiful. It's nice if it's a lovely thing. But as with software development, so with teaching, what matters is that it works, which takes me on from the agile development thing to this notion of software craftsmanship. And you'll notice similar language here to what we had on agile. That, yes, working software, responding to change, individuals and interaction, customer collaboration is important. But the words in bold perhaps matter more for at least some of us. And this notion of the well-crafted lesson, of not just a lesson that works, but a lesson that's as good as it can possibly be. And those of you who are still teaching, you know when that happens. Isn't that a lovely feeling when your lesson just so gels? And it's, you're there at the top of your game. You're there as the master craftsman teaching. And yes, being responsive to change, it does matter. But it also matters that we are adding value. They are learning something rather than just having an interesting conversation with us. And of course, we focus on the individuals and the interactions there in front of us in the room. But we also ought to think about the wider community and our contribution to not so much our own professional development as developing the profession. And participation at events like this matter. And yes, collaborating with our customers, but think more in terms of partnership there than mere collaboration. So it's argued for software craftsmanship, and so I would argue, take those ideas, apply those inside the classroom. Hoover-Nosh and I, again in Apprenticeship Patterns, the things we build for our customers can be beautiful, but they must be useful. Part of the processing compass of maturation is the ability to sacrifice beauty in favor of utility if and when it becomes necessary. And Laurillard's saying that teachers as design scientists would be expected to do these things, to keep improving their practice, to have a principled way of designing and testing. But look at the other two, and look how important community or the professional community is for that to build on the works of others and to represent and share their pedagogic practice. And she argues that pattern languages are powerful for this, and the outcomes they achieve and how they're related to elements of their design. Which takes me to Wenger and communities of practice. And yes, the bottom left corner here does matter, but the top right side of this matters so much as well. And your identity as a teacher, as a schoolmaster, as a head teacher, as a school leader, as whatever you see yourselves as, is important in that. And your participation in this wider community of practice. If we have this apprenticeship craft model of teaching, your participation in the guild is how that comes to be valued, how that comes to be recognized. Okay. The elephant in the room is, of course, assessment. And the level thing really doesn't work very well for that. James will know more about this than I do. We've got the whole badge thing going on with the Scouts. And isn't that actually a more helpful way of thinking about accrediting achievement in the classroom? If the child has learnt this, they have that credential there at a very granular level of the things they can do. And software developers do this too. Anybody here on Stack Overflow? Amazing place to go to get solutions to your technical problems. And they've gone into this badge thing in a really big way. And, some of these badges are really hard to acquire. To be a copy editor, you've got to have edited 500 posts on Stack Overflow. You've got to have asked a question with 10,000 views. So that's, some recognition from one's fellow professionals there. And, of course, people doing this in a school context too. And then Mozilla providing heavy lifting infrastructure to enable that to happen across an education system. And, here's a challenge for the ISC ICT committee. Why not implement Mozilla's open badge architecture on a server somewhere and start accrediting independent schools to award badges themselves? But it's not the credentials that matter. If you're trying for a place, or if your students are trying for a place at a Russell Group university, or for a job in the industry, then what matters is not their GCSE and A-level qualifications. Okay, it's a barrier, you've got to have those, But what really matters is who are the people you've worked with? What are the projects you've participated in? Can you show me what you've done? You know, where are your apps on the App Store if we're looking at the computer science courses, but similar things in other domains. And finally, he says at last, my journey from Roehampton to here. You know, you plug this into the sat-nav and it says, go this way, go that way, and so on. And we're very used to that. And we think so much in terms of curriculum in that way. If you do this, you get to that destination. Follow these steps, you get to where you want to go. But there's an awful lot more to the map than just that route. There's a whole landscape to explore there, rather than just a journey to follow. So, stuff on the left is metaphors with which we're very, very familiar. It's one thing after another, isn't it? We think of learning as a journey. We think of a destination that we want to reach. We think of our lessons as planned in a very linear sort of way. We think of levels of achievement. But over on the right-hand side, there's a whole other collection of metaphors that it might sometimes be helpful to think in terms of. Think in terms of the learning that takes place in the library, where there's much more autonomy about what you read than the learning that happens in the classroom, where there's a teacher in charge, there's somebody working through slides, one slide at a time, sort of thing. Think about the learning landscape to explore, rather than the journey to a particular destination. I think that's all I've got time to say. If you want to get in touch, I'm going to be around for the rest of the day. We're going to have a discussion about some of these ideas in here this afternoon, so come and argue with me about this then. But there's an email address, there's a Twitter thingy, and a blog which I hardly ever have any time to maintain up on screen there. It's been a great pleasure to talk to you this morning.